All right, finally been able to get out to the garage with one of my new 3D printed rotors. There's the load right there, 12-volt LED strip. And this is I think it's a 3-inch or a 2.5-inch magnet. Here, let me turn it up. And this is the JL94 circuit, the one from Sky Collector. At 12 volts, let me drop it down a little bit, it was a little high there. 12.4 volts. This is a bifilar coil, and I jumped it to make it one continuous coil because the JL94 circuit likes big coils. It needs a lot to trigger the 93 circuit to switch. So let me turn this off. And these are the ceramic bearings too, and you can see this beast. It's a big one, and this is a 3D printed housing. And I took Mr. G Law's suggestion and made the retaining ring, instead of round like on this guy here. I don't want to get it too close to the other magnet. Instead of round like on this one, which actually does, if I can get it on there, actually does make it a little bit further from the coil. I decided for this one here to make it nice and flat to it. And typical of the JL94, you got to get it going. But once it gets going, it flies. And if I turn it up, yeah, that's 14 volts. There's 12 volts. I have those retainers on there just to make sure the battery doesn't fly out. For the next one I'm going to try is this guy here with the big 4-inch magnets on it. But 3D printed braces, 3D printed coil housing, which is fantastic. For me to make stuff like this out of acrylic, I mean, it took me, a good hour or so just to make this new base so I can put different stuff on there. All right, ciao. All right, so I decided to hook up the big one before I upload it. So these are 4-inch magnets by 1/2 inch by 1/2 inch, and they freaking scream. I had to turn it down. I couldn't run it at 12 volts. This is with the Bedini circuit. Let me turn it up though. Once it gets caught, then it starts to fly. Yeah, see, there it goes. There's the load. So that's with the Bedini circuit, and it's really going fast. And let me turn it off. And so what I also used to get this 6mm shaft into these bearings is another 3D printed part. It's a bearing sleeve, I guess you'd call it. So this is 8mm. Oops, this is 8mm, and this is 6. And it fits perfect in there. So now let me hook up the JL94 circuit. Hold. I'm not sure when it stopped recording. My camera just ceased to record, but we're down to 6.9 volts on the JL94 circuit, and that thing is screaming. Look at how smooth that is. I don't know if you guys caught this, but there's no way I can build a coil manually like that. The 3D printer is freaking amazing. I don't know how much I didn't get recorded. I was over here yammering. So 3D printed parts, 3D printed bearing sleeves that turn a 6mm shaft into an 8mm. 3D printed housing. Freaking awesome. 6.9 volts. I don't know how low I can go. There's 6 volts. And that's pretty far too. The coil from the rotor. I can only imagine if I had it closer. 6, 5.4 volts. And that's still connected. It's slowing down, but not by much. I don't know if my tachometer can read this without there being a no, it can't. I wonder if I can read the side of it. No, I'm gonna have to put a reflector on it. So 5.4 volts. Let's see how low I can go before it stops. There's 5 volts. 4.4 volts. It's still connected. Let's see. 3.9 volts. It's definitely slowing down. Oh no, that's it. All right, 3.9 volts is, or probably 4 volts is the slowest I can go. All right, ciao guys.